Could a glass of water extinguish the sun? The solar system is vast and full of mystery, and even the people who have explored it don't know exactly what's out there. But the sun, big and bold as it is, has never been disputed. Nevertheless, the center of our universe won't always be there. The timeline for its demise is a long way off, but could anything be done to make it happen sooner? Could pouring a glass of water on the sun extinguish it? Before we get into answering this question, here's your reminder to subscribe to our channel and turn on notifications so that you don't miss any of our new content. Now for a bit of a science lesson. Just a little disclaimer first. None of us at Brightside are astronomers or astrophysicists, so this will be a basic rundown of the science involved. If there are any astronomers or astrophysicists watching, please feel free to share your knowledge with us in the comment section below. The sun is a star, and it's at the center of our universe. It's composed of 74.9% hydrogen and 23.8% helium, with the remaining 1.3% belonging to the heavier elements of oxygen, carbon, neon, and iron. Right now, the sun is about halfway through the main sequence of its evolution, which is a pretty good spot for it to be. It's stable, meaning that the pressure of gravity pushing everything towards the core is equal to the amount of energy from nuclear fusion that the sun's pushing out. The nuclear fusion processes in the core fuse hydrogen into helium, which helps the sun convert more than 100 times Earth's mass into energy. That's over 4,409,200 tons of matter every second. The hydrogen atoms are really the ones fueling all of this, but the sun is burning through that fuel pretty quickly with all the energy it gives off. According to the theory of relativity, giving off energy makes bodies of matter lose mass. This means that the sun's core is shrinking. As the core shrinks, the outer layers on the surface expand and experience a stronger gravitational force, which then puts more pressure on the core and makes the fusion process happen more quickly. This has been a continuous cycle for billions of years, and as the core has gotten denser, the sun has gotten brighter. In fact, astronomers think that the sun gets about 1% brighter every 100 million years. Cool, right? Want to hear something even cooler? Well, perhaps we should say hotter. As the sun burns brighter and gets bigger, it will eventually turn into a red giant. Once it reaches that stage in its evolution, it'll get so large that it'll actually engulf Mercury, Venus, and Earth. Don't get too excited now. This won't happen for another 5 billion years. The sun has enough mass and currently produces enough energy to burn for a total of 10 billion years. And it's already halfway through its cycle. Over the course of these next 5 billion years, more of this energy will reach Earth. In about 1 billion years, just 10% more of this energy will have an extreme greenhouse effect, much like on Venus. All the water in our atmosphere will dry up. In 3.5 billion years, the sun will be 40% brighter, causing all the oceans, glaciers, and snow on Earth to evaporate. Nothing will be able to survive. After 6 billion years, hydrogen fuel will run out. As soon as there's no energy pushing out from the core, all of that pressure will turn inward, forcing the core to collapse under its own weight. As it gets hotter and denser, the sun's outer layers will expand until it gets to that red giant stage we mentioned earlier. Now it will get big enough to overwhelm the planets closest to it. But we wonder if anything could happen to disrupt this process. We don't want to disrupt the process without giving ourselves a backup plan, though. If we took all of the sun's energy that reaches Earth each day, we'd have about 170 trillion kilowatts. And that's enough to keep us going for thousands of years without the sun itself giving us power. If we could get our hands on the amount of energy the sun disperses throughout the entire universe, then we'd extend our survival by millions of years. We guess solar energy really is the way of the future. Now let's move on to actually putting it out ourselves. Firstly, we'd have to find or make a cup big enough to hold the truly absurd amount of water it would take to put out a fire that extends for 2,351,362,145,523.5 square miles. But just for the sake of this video, let's say we have a cup and a way to get it to the sun. So what happens next? An astrophysicist would need special software to give us an exact answer, since nothing like this has ever happened in nature, and probably never will. On Earth, combustion needs fuel, air, and heat to occur. We use water to put fires out because they can't burn through the coating of water over their fuel. But there's no air in space, and water can't stop the thermonuclear reactions that cause the sun to burn. So really, we've just gathered all that water and brought it to the sun only for it to be burned as well. Our huge glass of water would actually make the sun get hotter and burn 6 times brighter. Once the actual water has burned away, the vapors containing hydrogen and oxygen atoms would get absorbed by the sun. The hydrogen would give the sun more fuel to continue its thermonuclear fusion processes. And the oxygen would act as a catalyst for another fusion process, which would create a new star. This new star would have twice the current weight of the sun and be composed of 48% hydrogen, 14% helium, and 37% oxygen. So pouring our gigantic glass of water onto the sun won't extinguish it, but it will actually create a whole new sun. How cool is that? This new sun, with an even greater mass than our current one, will produce exponentially more energy for us to live off. However, there is a downside to the formation of this brand new star. Remember how we said that once our sun reaches its red giant stage, it'll get big enough to engulf the planets closest to it? Well, the gargantuan size of this new star would immediately swallow them up. It would have a stronger gravitational pull on the other objects in our solar system too, changing the position and orbits. What do you think that new solar system would look like? If we don't bring that huge glass of water into outer space and pour it onto the sun, and that's a pretty big if, we don't know what NASA's planning, then it will continue its thermonuclear fusion and stay on its projected path of destruction as planned. After 5 billion years, once it's reached its red giant phase, the increased pressure in the core will allow it to fuse the heavier elements. In this case, it'll be helium into carbon. Once all of the helium in the sun has fused into carbon, the core will stabilize again. The outer layers, unfortunately, will keep expanding until they're blasted off, breaking away from the core and leaving behind a huge ball of carbon. This ball of carbon is now a white dwarf star, and the pieces that broke off are now a planetary nebula. White dwarf stars don't perform any of the fusion processes that other stars do, so it will eventually cool down to the same temperature as everything else in the universe, a few degrees above absolute zero. We know enough about our universe that we can figure out how and when it started, as well as predict how and when it will end. The human race might not be around to see it, but it'll still be a pretty awesome sight. Would you like to watch the sun go through the rest of its phases? Tell us in the comments below. Give this video a like if you learned something, and share it with someone who could fact check it for us. Until next time, remember to stay on the bright side of life, which shouldn't be too hard given that the sun's getting brighter by the second.